The history of AI engineering. This video is a part of a multi-video series going into what AI really is. I'll leave the link to the playlist in the description of the video. Last video, we discussed about deterministic and probabilistic system. Basically, a deterministic system is a system where if you put something in, you'll get something you already know will come out. A probabilistic system is a system where if you put something in, you'll basically not know what you'll get out. Normal software is deterministic. AI is probabilistic. So now what? What do we do with this probabilistic and deterministic system? We know that the model is a bunch of numbers that chooses tokens at random with a creativity variable that makes it choose random things, so it's not always deterministic. If we look back on how people used AI initially to now, the way the pros used it changed over time because the context window increased, the memory increased, and the capacities increased. How? I'll explain these with examples right after. I just want you to gain a big picture understanding first. It all began with prompt engineering, when the AI had barely any memory. If we think in terms of the three brain theory or the Troon brain theory, prompt engineering is the reptilian brain. It basically had zero memory, and you send one prompt and it's only useful for basically one prompt. It can't remember anything by the time you send the second prompt. So the instant instruction had to be good, and thus prompt engineering was born. So prompt engineering is kind of like this. You are a good chef, help me cook a dish. It'll help you as a chef if you tell it that it's a chef. If you don't, it's kind of confused and doesn't give you the right answer. Like if you said help me wash, it'll reply with something bad, and the model alone can't be steered, so you add a prompt to steer it. Then it moved to context engineering. The AI has more memory now. It's more capable of more complex tasks because it remembers more. It's like the limbic brain. It has some memory and thus has context and can execute things. It's still text-based because it's a text LLM or AI model. So the usefulness is it's able to carry out actually good textually based tasks. So you just have to give it good context at the start and refresh its memory once it forgets. Context engineering is like this. You are a good chef and your name is Gordon. You like lamb sauce, you have restaurants, you like really good food, and blah 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 blah, which is a bunch of other context. So then it'll help you out as Gordon, and it knows what it as Gordon likes. And the prompt can be overridden or forgotten, so you add context. Then it moved to harness engineering. It's like the neocortex. It has tons of memory. It can carry out plans and execute. The harness, or the arms and legs, and the restraint has to be good. The AI has enough memory now to not only remember text and context, it can now remember tools and what those tools did. So therefore, AI engineers attached tools to the LLM, saying to the LLM or large language model, yes, you can use these tools by saying commands to us. Then I'm guessing it'll move to foundry engineering, where it's basically unlimited memory that they will not hallucinate and will have memory that exceeds humans, meaning they can learn much better than humans and they'll be embedded into the real world as physical robots. So the hardware has to be good in that sense. The ideal scenario is we have hardware security in place alongside software security, and we design them with non-lethal components and non-lethal software. This should be possible since we've always figured things out. It's just wrappers inside wrappers. All the previous things are wrapped within the current things, like prompt is inside context, context is inside harness, and harness will be inside foundry. One thing to note is that an AI model is trained on all types of data, so it could say anything. This includes unlimited access to all types of information, even including the no-no stuff. So a harness acts as a deterministic system that is wrapped around this probabilistic system. It contains it and hopefully filters out anything bad before it goes outside to the real world or the real files or whatever. The harness is predictable, the model is not, but you can most likely get rid of all the bad stuff while keeping the model's creativity by putting a harness around an AI model. The harness allows the model to act, and it could act badly, so add a security layer. This is the security features implemented in harnesses. So harnesses are the tools and security. Think of it as like a brain and body model. The model is the brain, the harness is the body. The brain can only think, the body can only act. Putting this all together, an autonomous AI or an agent is a model plus harness, or a brain plus body. Model plus harness equals agent. A model that has the tools and security with the ability to act. I'll go deeper into these topics if you guys want me to. Just subscribe and click the bell to let me know if you want to watch more videos like these. And check out the next video in the series here, and check out the playlist in the description.